Hi everyone, this is the Unit 4 summary for Algebra 2R. The first thing that we're going to look at is quadratic linear systems and solving them algebraically. So here we're given a parabola and a line, and if I were to do a sketch, this is going to look something like, here's my parabola, here's my line. Usually they cross in two places, not always, but usually. So to find my solutions and solving this algebraically, I'm just going to plug one equation into the other. Both variables are solved for, so essentially I'm just setting them equal to one another. So we have x squared minus 4x plus 3 is equal to x minus 1. This is a quadratic, so I want to set this equal to 0. And I can do that just by subtracting over the x. That would give me x squared minus 5x, and then I'm going to add the 1. Plus 4 equals 0. Now I can factor t-chart and solve. This is an AM trinomial. So I'm looking for two numbers that multiply to 4 and add to negative 5. The factor pair would be a negative 4 and a negative 1. And then I always do an elongated t-chart because we're not just looking for the x values, we also need the y values. So I get x equals 4 and x equals 1. Now I need to find those y values, and I can do that just by plugging into one of my original equations. I always plug into the linear equation, the one that has nothing squared. So I have y equals x minus 1, and then I'm just going to plug in y equals 4 minus 1, so my y coordinate is 3. If I write my answer out in coordinate form, I'd have an x value of 4, y value of 3, and then same thing on the other side. I'm going to do y equals 1 minus 1, so we'd have y equals 0. So then my coordinate would be 1, 0. So there's my solution. That's where the parabola and the line would meet. Next, we are going to look at solving circle and linear systems. We're going to do this graphically. However, we could do that algebraically using that same method that you saw above. So to graph this first figure, that's going to be a circle. I know that because both x and y are being squared. And to find the center, I just take the opposite of these values here because it's what's being subtracted. So the center is a positive 5 and a negative 3. This value here represents my radius squared. So if my radius squared is 9, I know that the radius itself is 3. So we have a radius of 3. Now I'm ready to graph that. When I graph that, starting with the center at 5, negative 3, plotting that, and then I'm going to go 3 in each direction. I'm going to go 3 up, 3 units down, left, and right. And then I can draw in my circle. Not the best circle in the world, but it'll work. And then I want to graph my line. My line, the two things that I need to establish is the slope, which is the coefficient of x. If I don't see it, it's 1. My y-intercept, which is negative 5. So graphing that y-intercept first. 1, 2, 3, 4, 5. And then we use rise over run with our slope. So we rise 1, run 1, rise 1, run 1. I can already see one of my intersections there. Rise 1, run 1, and so on. And I can see my other intersection there. Now if I was actually doing this on paper, I would take my straight edge at this point, draw my line. You need to label at least one function. It doesn't matter which one. I'll label the line y equals x minus 5. And I would say circle and state those solutions. So circle them on your graph and then state your solutions in your work area. So my solutions would be over 2 down 3. And my other solution is over 5 and up none. And that's it. Next, we will look at our transformations. These are all based on quadratics, just your standard parabola. And if you add any constant to your quadratic, it would shift it up, whatever units you have, in this case C. If we subtract a constant, it shifts your parabola down. We'll say C units for now. And left-right shifts can be seen within parentheses. We reverse our logic in this. Minus, we would think it shifts to the left, so we reverse our logic, it actually shifts right. C units. And then plus, we would think it goes to the right, it actually goes left. C units. When you have a leading coefficient that is greater than 1, we say it is vertically stretched. And you say by whatever that number is, in this case A. I'll just put quotes around that because it would normally be a number. If your leading coefficient is a number between 0 and 1, we say it's vertically compressed by A. If we have a negative out front, so your leading term is less than 0, we say it's reflected over the x-axis, which really just means it was flipped upside down, essentially. So when we look at these examples, we can identify our transformations based on those rules. So this leading 4 out front would tell us that we were vertically stretched by 4. This x plus 3, that tells us we shifted either left or right, that would be to the left 3 units. The minus 7, that's showing that it would shift down 7 units. Now on the next one, we have to solve for y first before we can look at any of these transformations. I could easily do that by adding 5 to both sides. So we'd have negative 1/5 x minus 1 squared, and then if I add 5, we're going to have a plus 5 there. So that negative out front would tell us it was reflected over the x-axis. It was vertically compressed by 1/5. We have a left-right shift here. I know that because of the parentheses. So that would be shifting right 1, and the plus 5 just means it would go up 5. On the next one, same idea. This one, we just don't have a left-right shift, and we have a cubic function that's being transformed. That's okay. These rules apply to lots of different types of functions. And so again, the negative would tell us we have a reflection over the x-axis. The 3 means it was vertically stretched by 3. X cubed, that's just our parent function. That's not any sort of transformation that's going on. That's just the type of graph that we started with. And the plus 10 means we went up 10. You could see an absolute value function follows the same rules. We have a vertical stretch here of 4. We have a left-right shift. This would be shifting left 3. And we have an up-down shift that would be shifted down 2. So we don't reverse our logic on the up-down shifts, only on the left-right shifts. Using those transformations, that can help us look at the vertex of any quadratic. To look at the vertex first, we want to get this into vertex form, and we're going to do that by completing the square. So the first thing that I'm going to do is move this constant over by subtracting the 71 on both sides. So when I do that, on the left side, I'd be left with y minus 71. And then I'm going to put a blank on that side, which will be filled in a moment. On the other side, I just want my variables, x squared plus 16x plus blank. Now I want to create a perfect square trinomial that can be factored into a binomial squared. I use a little bit of a shortcut by dropping down that variable of x, taking half of that middle term, plus 8. Then I almost follow this path to fill in this blank. 8 squared gives me 64. What I add to one side, I add to the other. So then when I combine those terms on the left, we're going to end up with y minus 7 equals x plus 8 squared. I've already taken care of that. Now I could think of, if I were to factor this as an AM trinomial, it would factor into that x plus 8 squared. Not that you have to do that, but just to be clear if that's where it comes from. And then I can add the 7 to both sides, solving for y. We'd have y equals x plus 8 squared plus 7. Now I can state the coordinates of my vertex by thinking about those transformations. This would have shifted, we have a left-right shift here. We would have said it shifted left 8 units. So the corresponding x coordinate is -8. And then up 7 units would be 7. So there's my vertex. Now sometimes we have a leading coefficient of something other than 1 before the x squared. That's okay. We're going to start out in the same way by subtracting over the 170. So we would have y minus 170 plus blank equals, and then I'm going to factor out the numeric GCF between my two remaining terms. So that 170 is no longer on that side. If I factor out the numeric GCF, which is a 2, I'm going to be left with x squared plus 18x plus blank. I'm going to drop down that 2, keeping that as my coefficient. I'm still going to go into that binomial squared, using my shortcut of dropping down the variable, taking half of my middle term, half of 18, I get 9, square 9, we get 81. Now what I add to one side, I add to the other, but we have to remember we factored out this GCF of 2, so we have to think of this representation here as 2 times 81, which would actually give us 162. So that whole what we add to one side, we add to the other. This is now 162 that we're adding. If I combine my terms on the left, I would have y minus 8. And then I can solve for y just by adding that 8 over. We'd have y equals 2 times x plus 9 squared, and then plus 8. I can now state my vertex, just like we did before, thinking of our left-right transformation and our up-down transformation. So we'd have a corresponding x value of -9 and +8. So we always reverse our logic or take the opposite sign of what was in those parentheses. Next, we're going to look at converting circles into standard form. I know this equation represents a circle because, again, I have both an x squared and a y squared. So I'm going to group my x's together, include a plus blank. I'm going to do that completing the square idea again. So x squared minus 2x plus blank, and then I'm going to group my y's together in the same fashion, including a plus blank. So I have y squared plus 28y plus blank. I'm going to subtract the constant over to the other side, so I'd have -181 And if I add 2 blanks to one side, I better be adding those 2 blanks to the other side. So now we're going to end up with 2 binomial squareds. Dropping down the variable of x, half of my middle term, half of -2 is -1. We square -1 to get a +1. Same thing over here. We drop down the variable of y, half of 28 is 14. Square the 14 to get 196. What we add to one side, we add to the other. So I'm going to be adding a 1 and a 196. And when I combine all those terms together on the right, those would add up to a 16. Now I'm in standard form. I have my 2 binomials squared, and then that last value again represents the radius squared. So I could state the center being 1, -14. Yes, we always switch those signs. And just remember that value there represents the radius squared. So if I'm asking myself what squared is 16, I know the radius is 4. Could you actually write out that equation, say radius squared equals 16 and just square root both sides? Yep, we'd get radius equals 4. I'm not including a plus or minus here because the radius has to be positive. Next, we're going to talk about, again, our parabolas. We have 4 different ways we can see the equation of a parabola written. So first, we have parabolas opening either up or down. I can tell my parabola opens either up or down if it starts with a y equals. So that's going to be opens up or down. If it starts with an x equals, it means it opens either left or right. How can we tell? We look at the leading coefficient. So the leading coefficient here, if that is positive, I know our parabola opens up. If we had the standard equation of, let's even just say y equals 2x squared, I know that would open up because my leading coefficient is positive. If my leading coefficient is negative, it'll open down. For example, y equals just -x squared. That would open down. If it starts with x equals, I know it opens either left or right. If the leading coefficient is positive, it's going to open up to the right. And that could look as basic as, now we'd have x equals y squared. If you have a positive leading coefficient, like I said, it opens to the right. If you have a negative leading coefficient, for example, x equals -y squared, then that would open to the left. So we want to be able to write equations based on given some information. We were here given what the focus is and what the directrix is. Just to recap those, the focus and the directrix. Focus is a point, directrix is a line, and the definition of a parabola are all points that are equidistant from the vertex, and the focus creates your parabola. So we know the focus is 3, -4, directrix is x equals 1. So I'm going to actually pull up a graph in order to write this equation. So I have some graph paper here. Again, in this problem, we were told that the focus was 3, -4, and the directrix was x equals -1. So if I were to just do a sketch of that, to get to the focus, I would go over 3, down 4. That would be right there. There's my focus. The directrix of x equals 1 would be a vertical line crossing my x-axis at 1. So that's my directrix. X equals -1. Now the two things that we need to write the equation of a parabola is your vertex and p-value. To get the vertex is always equidistant from the directrix and the focus. So this whole distance is 4, halfway between. That's going to be my vertex. So I can see the coordinates of my vertex is 1, -4. When I draw the parabola, it always opens away from the directrix. And to find the p-value, I can count the distance from either the vertex to the directrix or the vertex to the focus. It doesn't matter. It should be equidistant either way. So that distance there is a distance of 2. So we have p equals 2. So now to go back to my paper, now I know that the p-value, like I said, was 2. The vertex we figured out was 1, -4. And now I'm ready to write my equation. Because this parabola opened up to the right, I know it's going to start with x equals. I would have positive 1/4p. I'm essentially just using this formula here. So you have to know your formulas. 1/4 times p. Our p-value we said was 2. Times y minus the y-coordinate. Remember, hk represents your vertex. Y always goes with y, so if I subtract that y value, subtracting -4, double negative becomes positive. Don't forget your squared. And then plus the h over here, which is just my x-coordinate. I'm not switching the sign. You only switch the sign when you're inside the parentheses. So then I can clean this up to be x equals 1/8 y plus 4 squared, and then plus 1. And that would be my final equation. Now this one, we're being asked to find the vertex, the focus, and the equation of the directrix. So first I would need to solve for y just by subtracting that 4 over. If I subtract that 4 over, it won't be there anymore. We'll have a -4. So I can get an idea of what this looks like because now it's equal to y and it has a negative coefficient, which means it's going to be an upside down parabola. I can state the vertex at this point. My vertex would be -2 and -4. My p-value, well, I know this denominator here is equal to 4p because my equation starts out with 1/4p. So if I take that 12 and I set that equal to 4p, it's very easy for us to see that our p-value must be 3. So at this point, to find the focus and the directrix, I'm going to go back to my graph paper to help me out with this visual. So now we just established that our vertex was -2, -4. And we established that our p-value was 3. So if I again just do a quick sketch here, it's going to help me find the focus and the directrix. So if I go back 2 down 4, there's my vertex. And I know it opens down because it had a negative coefficient. And the p-value of 3, that'll take me to the focus and the directrix. The focus will always be kind of inside your parabola. So if I go 1, 2, 3 units down, we get our focus. And that focus ends up being -2, -7. -2, -7. So you'll write that down for your focus. And then your directrix, I know it's going to be 3 units in the opposite direction. Now if I had an axis of symmetry here, our axis of symmetry would be a vertical line going right through the vertex. The axis of symmetry and your directrix are always going to be perpendicular. So again, if I go 3 units out in the opposite direction, and now I'm going to make that directrix, which would be a horizontal line. Again, here would be my axis of symmetry. Perpendicular to that would be my directrix. Writing the equation of that directrix, just ask myself 2 questions. What axis did it cross and where? It crossed my y-axis at a height of -1. So the equation of that directrix, y equals -1. So if I go back to my paper, now I can just state those solutions. Our focus was -2, -7, and our directrix was y equals -1. Next, we have a 3-variable system that we're going to solve algebraically. We're going to do that using elimination and substitution. Now I don't have a whole lot of room here, so I'm going to switch again back to my other paper. So now I have a little bit more room to write. So you're probably writing in your packet. Make sure you write a little bit smaller because you need plenty of room for these and you want to stay organized. First thing we always do is number our 3 equations, obviously 1, 2, and 3. I want to decide which variable I'm going to eliminate. I can either eliminate x's, y's, or z's. It's kind of a personal preference, but I think the z's would be easiest to eliminate because I have those 2 matching terms. I have both 2 z's in there. So my goal is going to be eliminate z. I always write that goal so it's very clear to the reader exactly what I'm eliminating. So if I want to eliminate z, I might start with working with equations number 1 and 3 first. You always want to show your reader what you're working with. And again, just try to stay organized. I start by writing those 2 equations out as they were. And if I want to eliminate these z's, I can't right now because they're not opposites. So to get them to be opposites, I need to multiply one equation by -1. It doesn't matter which equation that I multiply by -1. I just want to make sure I multiply both sides of it. So now I just do a little squiggly line. I'm going to rewrite equation 1 as it was. And then equation number 2, I'm going to multiply out that -1. Don't forget to multiply both sides. Now I can simply combine these 2 equations or add them together. We will get -2x plus y. Those z's are going to cancel each other out, and that's going to equal a -4. I'm going to name that equation number 4. Now we're going to go back to the drawing board. We're going to find 2 equations that we want to work with, and again, sticking with that same goal of eliminating z. So I'm going to pick equations 2 and 3 now. Do I have to choose number 2 and 3? No, I don't. But my goal is to use 2 other equations to still eliminate z. So now if I want to eliminate z, I'm looking at these terms and I'm going to say 5 and 2, well, those both divide into 10. So I want to make one of them into a positive 10, one of them into a negative 10. So I'm going to multiply the top equation by positive 2. And the bottom equation, I'm going to multiply by a negative 5. Now I just do a little squiggly line here because I'm not actually adding them together. I'm just rewriting at this point. Now I'm ready to add these together because again I have those opposites. So if I combine, I get negative 10x plus 19y. Those z's are going to cancel out. That's good. That was my goal. Equaling negative 48. I'm going to call that equation number 5. Now at this point I have two equations with just two variables. This goes back to our Algebra 1 problems. Two variable systems. I take equation number 4 and equation number 5. So I'm not ready to add them together because I don't have opposites. Now I'm no longer eliminating z. It's already been eliminated. I don't have any z's here. So it really doesn't matter what you want to eliminate, whether it's x's or y's. I think the y's are easier to eliminate. So I'm just going to multiply that top equation. The opposite of positive 19 would be negative 19. So I want this to be negative 19y. So I'm going to multiply both sides by negative 19. Then I'm going to go through, multiply out. That will give me 38x minus 19y equaling positive 76. Bottom equation stays as is. I have those opposites now. And I can add them together. Now we're left with 28x. Those terms cancel each other out. And then we're left with combining those together. Negative or positive 28. We're going to divide. We get x equals 1. So I now have one solution. I'm going to take that, plug into either equation 4 or 5. Doesn't matter which one. I think equation number 4 looks a little bit easier. And I know my x value is 1, so we have negative 2 times 1 plus my unknown y value equaling negative 4. We have negative 2 plus y equaling negative 4. And then we get y equals, adding 2 to both sides, negative 2. And then I'm going to take both x and y and plug into one of my original equations. Doesn't matter which one, just back into one of the originals. I might pick equation number 1. So we have 2 times our x value of 1 minus 4 times our y value of negative 2 plus 2 times z equals 4. Now I can solve for z. So we end up with 2 plus 8 plus 2z equals 4. I know those are going to combine to 10, and I'm going to subtract 10 from both sides to get 2z equals negative 6, and dividing by 2, we get z equals -3. And for the last problem, you're going to need your graphing calculator. I've typed into y1 the first equation and to y2 the second equation. And we're trying to find out the x values of where these two functions intersect. So we have a cubic function and a linear function. When I graph these, it's very easy to see where those intersections are. But I want to get exact values. So to do that, we want to calculate something, so we do second trace. I select option 5, which is intersect. I can scroll over to any of the intersections, and I hit enter 3 times. It doesn't have to be perfectly on it, but just close. Enter, enter, enter. And then you're going to look at the corresponding x value and do your proper rounding. So this value, kind of hard to see, but it would round up to -1.4. So it can't be that one. I'm looking at which one is not the solution. So if I bring back my calculator, repeat that same process, second trace, and then 5. I'm going to scroll over to my other intersection. Again, doesn't have to be on, just close. Enter, enter, enter. And we get an x value of approximately -4.6. So that can't be it. I meant to tell you there was a typo here. This was supposed to be 1.0. This option here was supposed to be 1.0. So now if I bring back my calculator again, do second trace, option 5, and then scroll all the way over to that last value. And then enter 3 times. Enter, enter, enter. And that's going to round up to 1.0. So it's not that one. There's my answer. That's it.